Hi, in this Let's Create series, we're creating the classic Simon memory game, where you have to remember the sequence of lit blocks. It will work like this example here. We'll have a variable size playing area, so you can have as many tiles as you'd like, and each tile will have a unique sound too. This episode focuses on getting the light tile created and the game board set up. Let's get started. Today I'm using Unity 6 and will just use the Universal 2D project. The old core SRP pipeline would work just as well, we're not doing anything fancy. I've called the game Simon. Okay, for this Simon project we're going to need a few simple things in our scene. Firstly, let's create the two core objects we'll need. We start with the GameManager, so right click, create empty and call this GameManager. To this, we'll add a new script called GameManager. As always, I like to keep my directory structure nice and tidy. So I'll create a new folder called Scripts and move the GameManager script in there. We'll come back to the GameManager in a bit, but first we'll create the tile. Right click to create a 2D object, sprites, square. This one we'll call tile. And we'll add a script to it called tile. Again, move the tile.cs script into the scripts folder. As we're going to want to click on these tiles to interact with the game, we'll need to add a box collider 2D to them. We're also going to arrange these tiles using the fact that they are 1 unit wide and tall when we create them. To ensure there is a gap, click the lock icon so we can change all the scale at once and set it to 0.9. If you saw my recent lights out video, we did the exact same thing there. That's it for setup for now. Let's dive into the tile code. Okay, to start we're going to add the variables. These are all going to be private as we have no reason to access them from outside the tile class. We will want a reference to our GameManager. This is so eventually we'll call a method on here to handle the logic of lighting up the tile and playing sounds. You could handle more of that within a tile if you like, but I have a preference when making very simple games like this to keep as much of the logic in the GameManager. We will also need the sprite renderer of the component. This is because currently we have a white square, but we're going to use this to alter the colour of the tile to light it up. Then we'll have a private int called tileID. This is just holding the state of which tile this is. And a private colour. Although Unity uses American spellings for the type, I still use the British spelling for my variable. Apologies if this confuses you, just one of my quirks. The first function we want to code up is an initialization function to set all of these variables. Create a new public void called init. This takes the GameManager, tileID and colour. We'll simply map all the past variables to our local ones. We have to use this dot to reference our local names because the names clash. Some people like to use underscores like underscore tileID to disambiguate like this. It's just my preference to keep them the same. Then we can set the sprite renderer by using getComponent of type sprite renderer to get the reference to it. Then finally, we'll make sure the tile is off by calling turn_off, and we'll create that function now. This is a public void because we're also going to want to be able to control the light from the GameManager. And this simply will set the tile to a darker version of the past colour to indicate it's off. To do this, we use sprite renderer.color and we'll set it to colour times 0.3f. You can happily multiply a colour like this, and it'll just alter the underlying RGB values that make up that colour. And so by multiplying it by less than 1, we move the colour closer to black so it'll appear dimmer. Whilst we are here, we'll make the opposite of this. Another public void, so we can call it from the GameManager, called turn_on. This simply sets the colour to the colour we set in the initialization. The final thing to do in this script would be to implement the onMouseDown function. This is going to call a function on the GameManager. As we haven't written this yet, I'll just put it here in a comment and we can uncomment it later when we do. This will be GameManager.playLightAndTone passing in the tile ID. That'll be responsible for turning the light on, playing the audio, and checking if it is correct or not. It's that check for correctness, which is why I've put all the logic in the GameManager, as we'll need a call to do that anyway. Back in Unity, we should make the tile a prefab so we can use it repeatedly. Create a new directory called prefabs, then you can drag the tile in there. And delete it from the scene. In the GameManager.cs script, the first thing we want to do is to be able to create a grid of tiles. So create a new header called Game Setup. This will contain our settings for the size of the grid. We'll define the grid size by the number of rows and columns. These are both serialized private ints. As we want to be able to set them in the inspector, it isn't something we're changing during the game. I'm going to default to 3 rows and 4 columns. Also, we can add a private int called numTiles. We'll pre-calculate rows times cols into this later to save us having to keep calculating it. Then we'll just need a private array of type tile called tile, which will drop all of our instances into. The other things we're going to need are a couple of object references. I've used a new header here called GameObjects to keep them separate. To this, we'll add one of type tile, which will be our tile prefab, and another, which is of type transform, which will be our game area. We haven't created that yet, we'll do that in a moment. This is just an object to act as the parents to put all of our tiles under. This way we can move them around and scale them just using the parent. We can now create a start method, which is called when the game object is started. And we'll use this to create all the tiles we want. So firstly, let's cache the numTiles value by taking numRows times numCols. We're going to use this in lots of places. Now we know how many tiles we're going to have. We can create our tile array as a new tile array passing in numTiles. To create them, we're going to use a standard for loop with a variable int row going from 0 to numRows, and similarly one iterating over numCols in a col variable. This gives us a row and column, which is great for positioning the tiles in a grid. However, we'll also want to make that one-dimensional so we can use it as an array index in our tile array. So create a new int index, which will be row times numCols plus col. Hopefully that makes sense. Once you're on the second row, you'll have done numCols tiles, which is why we multiplied by that. Don't forget these are all 0 up, not 1 up. Okay, now we've got our index, we can instantiate our tile prefab into position index in our tile array. The second parameter here is our game area, which will put the initialized tile as a child under the game area. Then we can call init on the tile we've just created. To this, we first pass the game object, which as it's the game object script we're calling it from, we can just pass the keyword this to indicate the current object. Then we pass the index so the tile knows who it is. Finally, we want to pass a color. Because we don't know how many tiles we're going to have, we need a programmatical way of creating a range of colors. For this, we'll use color.hsv to RGB. The first parameter is the hue. This is essentially picking where on the color wheel you are if you've ever seen a color picker like that. For this, we do index divided by numTiles. Both index and numTiles are integers, so by default that division would be an integer. So we must cast one of them to a float, so we correctly get a number between 0 and 1. If we didn't do that, it would always be 0. Normally here, you may subtract 1 from numTiles, so the smallest index maps to 0 and the largest to 1. We don't actually want that because a hue of 0 is equal to a hue of 1. So to keep different colours, we don't want to go back to 1. Then we can fill in some constant values for the saturation and value. We want them to be quite vibrant when the tiles are lit up, so I've chosen some high values here of 0.8 and 0.9. Now we just need to position the tiles. We scale the tiles down so they're just below 1 unit wide and tall. This means we can just use the values of row and col to place them on the screen. All we need to do is make sure they're centered. To do this, we need to calculate a starting offset where col or row 0 will be. For the rows, create a float called row start, which will set to numRows divided by 2 minus 0.5. That's half the width, which will shift it left, and then we just need to take off another 0.5 because that's half the width of the tile, so it is centered. This will place the first row in the top left of our screen. Col start is very similar. However, this time we take minus numCols because we want the cols to start to the left of the origin, which is in the negative direction. Now we have these, we can set the position of the tile we've just created using transform.localPosition. We're using local position because we want to set it with respect to the game area's position, not an absolute position in the world. This is going to be a new vector 3, where the x, which is our horizontal axis, is going to be col start plus col, and y will be row start minus row. Remember, this is minus because we're going down the screen from top to bottom. Z we just set to 0 as we're in 2D. Jumping back into Unity, let's test out our board creation. Firstly, we need to create a new empty game object called GameArea to act as the parent for our tiles. We'll set the Y value to 1.5 to bring it up slightly off the center, so we have space for buttons below. Then, on our GameManager, we can drag on the tile prefab and our new GameArea. Hitting play, we can check this out. The tiles are darker because we're not pressing them yet, but they are a bit hard to see with that blue background. Exit out of play mode. Then we can select the camera and change the background to black. Now when we play, the tiles are a bit more easily seen. Don't worry that they're still dark, they're off, that's the point. The problem we have here is the more tiles we add, they just fill up the screen. We want the game area to be a static size, and then we could just scale the tiles to fit within that. Back in GameManager.cs, at the end of our start method, we'll scale the game area to accomplish that. Let's make the game area take up a fixed amount of vertical space. As we're using an orthographic projection, the screen is 10 units high, plus and minus 5, so it should be less than that. We moved our game area up 1.5 units, so if we make the game 6 units high, that will mean it's between minus 3.5 and 4.5. That's nice as it gives us a little gap at the top as the border and still space below for our play button later. So to do this, the scale is going to be 6 divided by num rows. If there were 6 rows, this would be 1, and each tile would be 1 unit big. If num rows were bigger, this would be smaller than 1 and would shrink the tiles. And if num rows were smaller than 6, this would be bigger than 1 and scale up the tiles. This only works in the vertical direction. If you add too many columns, they're still going to go off the edge. I'm fine with that for now. You could add in more logic here to also bound the scale based on the horizontal size. Now we have the scale, we simply take our GameArea.local scale and set it to be vector 3.1 multiplied by the scale. Using vector 3.1 just means that we'll scale it the same amount in all directions. Now back in Unity, we can test out different board sizes. We can see our defaults give us bigger tiles now. We can take this to the extreme with just 2 rows and cols and get really big tiles. Or we can say do 10 rows and cols and get lots of small tiles. This creates a really nice colour square effect. That's it for this episode. In the next episode, we'll add up the varying sound to each tile which plays when you click on them. As ever, the full code is in GitHub and linked in the description below. See you next time.